Hi, I'm back again. It's Kevin here, and a brief discussion about where we're going with the D49 project. While it's very nice to have a very defined plan for this kind of project, I find that a bit challenging, really. I find if you want to make progress, you need to be flexible. So rather than define a plan, what I'd rather do is define a strategy. And the strategy, as it stands at the moment, is to complete the chassis that I have and get it as far as running on air before I make any further significant investment. Obviously, the major investments for this project are going to be a boiler, and unfortunately, I just do not have the experience or resources or tools even to attempt that. Certainly, this is going to be quite a big boiler, not massive, not like a Pacific, but big enough that I would rather it was made professionally and probably welded rather than silver soldered. Though that is a decision that will come in time. The challenge basically is to get a boiler that is going to be as reliable and as robust as possible. Not that I intend to abuse or misuse it at any point, but just to prevent any accidents happening in terms of damage to the boiler. I mean, modern locomotive boilers don't explode. They just don't. There's no history of that having happened. They can fail, however, and some of the failures can be a little bit embarrassing and challenging. I mean, a major steam leak at the cab end can be difficult to deal with, and also risk burns of one sort or another. Having said that, probably the most likely cause of a major steam leak would be the breaking of gauge glass. So one has to just remember that when you're dealing with steam at pressure, even the relatively low pressures we're dealing with, it's a dangerous and pernicious material and can cause a lot of human damage rather than physical damage, I would say. So, what is the strategy? As I said, build the chassis first. The process is going to be a bit iterative. We're going to do it a bit at a time and see where that leads. One thing that's really important when you're doing this kind of projects is thinking time. So after a day in the workshop, I will take things home with me. I'll take the drawings home and maybe the parts I've just made, and just have a bit of a longer consideration of what I've done and what I'm going to do next. So as I left you last time, I had just completed this, and the plan was to weld that into the plate. Having looked at this quite a lot over the last several hours, what I've decided is that I probably want a better finish on that face than I have at the moment. So one of the next projects will be to see how I can improve that face. Now the options I have are to stick it on the mill behind me and try and take a skim off it, but I don't really want to take too much off. And the other thing, and what I will try before I start, is putting it on the surface plate with a bit of reasonably aggressive wet and dry paper, and to see how much of what I'm seeing here is visual and how much is actually not flat. So this is number 60 paper, and what we're seeing here is this is definitely not flat. With any sanding operation, there's a risk of kind of not being absolutely flat on the base, but this is as flat as it can be. And these two edges are distinctly raised compared to the center, which is going to be the bearing surface. Not quite sure how to proceed at the moment. I think I might give it a bit more sanding, but if it doesn't start to come out looking flat, it's going to go on the mill and we'll take a skim with the mill. Okay, so I gave up and I've taken a 5mm skim on this on the mill and given it another sanding, and quite frankly now that's a nice flat surface. It's okay with the the square, so it wasn't quite flat before. It was high at either side. So now it's flat. It's got a bit of texture, but I'm not unduly worried because that at least gives somewhere for oil to sit once it's operating. So that bit's done. Need to clean this off and weld the pin in that side, but that's as far as we're going with that today. So here's the bogie with the pin now welded into the plate. That was a bit more challenging than I expected it to be. Basically I used TIG welding rather than anything else. I wanted to basically get this into one piece of metal. Initial attempts were okay, but they looked like they were developing cracks. So what I ended up doing was puddling the whole thing so that the two steels became alloyed one way and another. That resulted in putting in rather more heat than I expected, which resulted in the plate becoming less flat and straight than it was. So it had to have a degree of percussive adjustment in order to straighten the pin up and flatten the plate out again. So it's now a reasonable, good turning movement on there. On the underside, I made a brass bush there so that there's a degree of lubricity and at least difference of metals between the plate on the bottom, which is a keeper for the block, and this, which is basically rebated a bit in the back here so that it bolts hard down onto the main block, so that becomes like a solid thing. First time I've used a 0BA. So that now is finished and is ready to go back onto the engine. That plate is bolting back into place there, but I'm not doing that just yet. So Evaporust is a great favourite in the maker community on the internet and on YouTube. So when I got a chance to get a pot of this, cheap, I had to pay for it. I thought I'd give it a try. So I'll get rid of this first. This was a set of feeler gauges that unfortunately got out in the rain and were rather rusty. So I just thought I'd try them in here and see how it worked out. I mean, they actually look as though they might become usable again. I'll get rid of the Evaporust off them and then give them a squirt of WD-40, I think is the correct medicine at this stage, to get rid of any water from them. But actually, yeah, these have come up surprisingly well. A bit stained, but that doesn't matter as long as the rust is gone and I can actually use them again. Those ends didn't get in as much as the others. Right, so let's just give these a squirt of WD-40. And put them to the side and we'll play with them later. Right, so one of the magic things about Evaporust is it is not corrosive and it doesn't hurt fingers. So it says, my goodness, what happened to the rust? That is really impressive. There is no sign of rust anywhere on these. There's still a bit of mark and staining, and I'll give them a little polish with the I don't know, with something abrasive, and yeah, it just wipes off, and see where it goes from there. But that is actually a cracking result and a lot less effort than it was doing the driving wheels. So impressed I am. That's one set. Since it hasn't got underneath the bearings, but they didn't look rusty yesterday. Okay, well that is very impressive indeed, and Evaporust is definitely going to stay in my favourite things to use. Wow. Oops. That's one axle. this is the other axle. Yes, maybe I should have taken the bearings off the journals and the apparatus we've got in there as well, but to be honest, I wasn't in a hurry to lose any material off of that. Not that this should take anything off, but wow, how impressed am I that this stuff works that well. Great, so the stuff is reusable, which is brilliant. So that pot is going to stay like that with its lid on that says evaporust, and next rusty thing I've got is going straight in there. So here's just a quick shot of the setup I'm using to clean up the wheels. What I've got is an old centre drill with a broken tip in the chuck to provide a driving centre, and a rotating centre in the other end. Not running the lathe very fast and using Scotch-Brite. Brilliant stuff. Just so as you know, this came from Sainsbury's. This is pan scouring Scotch-Brite. It's every bit the same material as is used for the engineering stuff, except it's a single grade, the green grade. But generally it's a hell of a lot cheaper than buying big packs or even small packs from various engineering outlets. So I'm just going to quickly run these with Scotch-Brite to clean any of the dark colouring off the wheels, and then I'm going to put them back in the bogie. Hi, I started the video today talking about the strategy to approach a rebuilding of an engine like this, and what I was going to do to try and get the best out of what I was going to do. So the other aspect of doing this is tactics. Now, tactics are different from strategy. Yes, last time we spoke, I talked a bit about being careful to keep things together and use methods of storing things. One of my tactics is to rebuild stuff as soon as I've got the bits done. So today has been putting the wheels back on the bogie, and I had failed in my own tactics, because what I did is I very carefully marked the wheels as to which set they were, because I've been there before and find they don't fit back elsewhere. What I didn't do is I didn't actually record the underkeeps. So that's these. They all look to be very similar, but you must remember that somebody has done this as a one-off exercise, and guess what? When I started putting them back together, because I hadn't marked them, it's taken me an hour to put 4 axle keeps back on. If I had marked them up when I took them off, then it wouldn't have taken me so long. I wouldn't have had to fiddle about so much. I still didn't find a 7BA screw that went on the floor, so I put one new 7BA in there just now, and I'll cut it to length next time these come off. They're coming off again because, if nothing else, I'm going to be painting the bogie at some point. So that's, they'll come off again for that, and then I will fix a screw that's now slightly too long. So, yes, tactics. The point I made about strategy was that what I wanted to do was to complete the frames and the motion and have the thing running on air before I dove into any other major expenditure like boilers or tenders. So it's now a case of just carrying on, and the next thing to do is going to be to look at the buffer beam. So let's get the drawings out and see what we have to do to sort that out. So back to the challenges with the drawings. If you look closely here, you'll see that the angle is just shy of the end of the buffer beam. Really no dimension there, or nowhere to realistically make dimensions. So my guess here is we'll look at the engine and take a dimension. Oh no, we won't take a dimension for that because that doesn't really help. So that's where the angle was originally. So I'll just see where my 1.5 inches comes to that. So that is, I guess, about a 32nd of an inch short, lining up with that. So if we cut the angle 32nd of an inch short of 1.5 inches either end, then we'll be about right. So what I'm going to do is scribe it up, cut it on the saw in between my two scribe lines, and then finish the scribe lines with the end mill. So just to give you a quick introduction, my bandsaw, this came from Lidl and has been modified with the platen, which is a lump of steel, 1/4 inch steel, which I cut to fit it. There's lots of instructionals on YouTube about converting these handheld bandsaws to this kind of configuration. It's basically fixed to the wall with a mixture of cable ties and brackets and bits and pieces that were lying around. And it's a very useful and very important tool to have. Essentially, when we're doing machining, we want to minimize the amount of time and effort we're putting in using machine tools to finish things off. So in terms of cutting things to size, this is a very useful implement. And I'm going to use it just now to cut the angle for the buffer beams, and I'll cut the length of the buffer beam itself before we put it onto the mill in order to finalize the dimensions. Here we go, same setup again. What I'm going to do is I'm going to cut it to the scribe lines, which I have done, and that should give me the dimensions I need. It's not a massively critical dimension, this, it's just nice to have it neat and the same on both sides. That's odd. Okay, I'm just going to stop and check that dimension because it's not quite looking right. All right, okay. Still a bit to go. Okay, so the first cut I did was climb milling, second one was conventional milling. So the final one I want to take is climb milling. I've got some space, another couple of thou, that's all I need to do. And that should give me a very nice finished surface. Final dimension check before I take it out, and that is spot on. Here's the file. might just sand the inside of that a bit because it does look a bit rough. Problem of using second-hand metal. So now we're just going to trim the buffer beam ends to the scribe line. I've cut them reasonably close to the dimension on the bandsaw, and this should be a quick operation just to get where I want to get to do tonight. Spot on first time. Lost the file, never mind, I don't want to do this end. Bit more to come off this end. Another 5. So that's the buffer beam to size, good ends, just need to get rid of those edges. Where's my file gone? So now we've zeroed the DRO, and the centre drill is sitting right spot on above the dead centre that was marked up on the bench. We already start drilling. What I'll do is I'll drill the first 3 holes, and then we'll look at how we set out the 6 points for the rivets on each side. So what I've set up is a pattern based on the rectangular layout. We've got a pattern 2 holes by 3 holes. The starting point is minus 131299 in X and 0.56224 in Y. Half an inch increment in X and 0.56248 increment in Y. So now what I'm going to do is I'm going to press run, and this should take me to the first hole. So before I do anything else, I'm going to run the axes and make sure I'm landing on each of those holes in turn. So I haven't bothered showing you the rather long drawn out process of drilling all the holes for the buffer beam or for the angles in the back there. Quite interesting trying to get everything in the right place and lined up with the existing holes in the frames, which don't quite match the drawings, but there's no dimensions again for exactly how they go. So the next process for this is going to be riveting the buffer beam onto the angles. This is really an exercise in fitting so far. As I said, I've tried to drill to dimensions as far as possible. I only had one minor problem in the whole process, which was breaking the end of my 1/8 inch center drill. That was solved by using a 2.5mm tungsten drill at as high a speed as I could get on my mill, but that was it, all done, all clear. So before I actually start riveting this, what I'm going to make up next is a test piece and then start playing with riveting techniques. This is not something I've done at all on this kind of scale with these kind of materials. I have done riveting before. My toolbox here was an actual exercise in riveting aluminium. I went on a little one-day course about riveting for aircraft, as I did fancy at one point building an aircraft or maintaining or repairing one, but never happened. So here I am back with steam engines, and here we go with riveting the buffer. Here is a nice picture of Murray Shah as she was in about 1929, just a few years after she entered service. We are probably aiming at something like this as an end result. There's many reasons for that, not the least of which is that the tender drawings and availability relate to what she was running with then. All the Shires lost their original tenders in the 1940s as they were taken off and put on V2s and B1s during the war, because the D49s didn't end up needing water scoops for troughs because they weren't used in those kind of areas. So this may be what we end up with. Then I've got a question of whether there's a Westinghouse pump going on it or not. Anyway, thanks for watching to the end of the second episode of this probably quite long series of videos about this project. Please do leave comments in the comments about what you see, and of course, if you're enjoying this, if you like this, please do subscribe. Thanks. See you next time.